Hello all, good morning, good afternoon. This is Dante Ferrario from Fluitech. I welcome you to Lubrication and Reliability Virtual Summit 2022. Today's topic will be understanding oil analysis reports, and to enlighten us with some information, we have Umut Arslan. Umut is working for SGS Turkey as a diagnostic and training executive. So he will be doing his presentation about why do companies do oil analysis reports, why do they spend money on that, what actions can they take later. So, and this is going to be a hybrid session. So we have Umut live, but there is going to be a recorded presentation. So if you have any questions, after the recorded presentation is finished, we can do a Q&A session. All right? So
great.
Let's start.
Let's go.
Hi everyone, my name is Umut. Thank you for having me here. We are to look at the understanding of oil analysis reports. Let me introduce myself. My name is Umut. I'm graduated at chemistry department at Turkey. And I would like to thank Sanya and LRVC family for inviting me, such a valuable organization. And when I look at the speaker list, I'm proud to see my own name among for them. I attend as a visitor when it was with first held in 2020, and now I'm here for a speaker. I started as a young analyst at Oil Condition Monitoring Laboratory at 2011, and during this time I faced all type of used and unused oils and experienced ASTM methods, and such as I analyzed diesel engines, turbine oils, gear oils, and transformer oils, and all type of oils I can't count right now. And in addition, to my analyst role, I worked as a device and equipment specialist. I took care of a calibration of and maintenance for all laboratory equipment and supplied consumable materials which all device laboratories devices needed, and determined their standard deviations and ensured as for the sustain of the operation, and by taking instantaneous quick actions. In the next period, I started my studies to find the answer to the questions at why oil analysis is done and how to diagnose and how to make recommendations. That's very amazed me, and I found an opportunity, and I went to UK and France for diagnostic trainings from valuable professionals. After all, I took the MLA2 and MLA3 exams and succeeded in getting the certificate from the ICML. Currently, I have diagnosed more than 110,000 samples until today, and still diagnosing oil analysis results in my country. I assist maintenance professionals, maintenance engineers, and consult them and preparing trainings in Turkish industry. And now I'm volunteer at ICML committee, exam committee, and associate member of the ICML. After short introduction, take a look at before importance of oil analysis at reliable maintenance. I asked when I visited the facilities, every training, before training, why are you interested in oil analysis, or why are you doing oil analysis? Why are you paying for this? Or how often do you have oil analysis? My dear friends, you know the critical level of the equipment. You work in the field. There are equipment that are seriously expensive and can put the field at serious situation in case of failure. Let me go back at the first question. Why are you doing oil analysis? Just as we do not know what is happening in our internal organs and we have a blood test, the same is true for the oil and machinery relationship. And analysis of 60 milliliter of sample will help you easily overcome these problems that may arise in the future. My second question is why you are paying oil analysis. For example, varnishing a turbine system, which may occur as a result of oil degradation, may cause downtime of the refinery, resulting in the failures and cost of $1.5 million. Is the money to be paid for oil analysis important for such a critical equipment? Let's look at the answers. Oil analysis benefits. That's maybe that's basic one, but take a look at deeply. And first of all, occupational safety on fields in the case of malfunction, especially if this is an unexpected malfunction, a serious cause environment occurs at the facility. Arranging personnel, finding spare parts, or depending on the criticality of the equipment. If this is a transformer, fires, explosions, etc. And second one, reducing equipment damage and maintenance costs. If the health oil is good, if the oil is good, the life of the equipment will be good and better, and you can use long term. If the contamination level is high, it can be eliminated with simple filtering. Or if there is a water contamination, it will be possible to eliminate the problem at its source. This is important. Maybe this is basic action will be safe from bigger problems. Avoiding unnecessary part replacement, and third one, improved equipment. In the event that the wear conditions of the equipment are closely monitored trends in the oil analysis results, if it's not increasing trend, and in addition, if the machine is monitored with the condition monitoring tools, unnecessary part replacements will not be needed. Another one, improved operational safety. An example again from the transformer oil analysis. The monitoring combustible gas rates, that's important. It's called DGA, dissolved gas analysis, because higher rates indicate of arcs, sparkings, acetylen, methylene, carbon dioxide, methane gases. That's really important to follow the trends. Or another example, diesel engines, decreasing of the viscosity or lower flash point indicates possible fuel dilution. That indicate possible diesel engine failure. You have to check fuel injection system for correct operation and adjustment or any leakages. After all results, the piston phase seizure or fires or breakdown of diesel engine in the middle of the sea, if this is a marine engine, main engine. Unnecessary oil change and sustainable environment. That's really important for these years, for whole world. And you can solve possible failures only changing oil. You need to determine root cause of the problem. And for example, if we talk about in turbine oils, higher varnish rates at the lubricant, you have to remove varnish from the system with appropriate techniques. You can't, you have to change before. When you are changing the oil, you can prevent high varnish rates. If you change oil with higher MPC rate, you'll be also contaminate your new oil with contaminated system. That you'll be see your new oil antioxidant levels will be decreased considerably before using it. Therefore, we must do oil analysis before taking an action for reliability and sustainability. Take a look at oil analysis steps. Oil analysis steps, 3 of them, and first of all, sampling, analysis, and diagnostic, and final report before final report recommendations. When we look at the sampling, that's really important steps as all the others, because if you can take a representative sample, such as without circulating oil or out of operating temperatures or sampling from bottom or after topping up, etc., you'll probably get wrong answers, wrong results. And after all, you'll take wrong decisions and finally wrong actions. That's very important. Take a look at oil sampling guideline. That sampling at operation temperature, that's really important. When you sample without operating temperature, such as maybe cold, you can see behavior of oil or oil characteristics at, because we are looking at the characteristics of oil at operating temperature. For example, sampling from engines at cold, you can find higher water content too, or sampling hot, maybe you can get higher results due to the results of water condensation. I experienced that this situation, especially for transformer oil sampling. This is another issue. But use sampling points with same intervals. That's another important point, that for calculate diagnostic results of future trends, detect for possible failures to get for healthy data. Fill the sample bottle, percentage of 80, not more, for total capacity, because that's important, especially before preparing sample shipping to the laboratory, and when the analyst take the sample for homogenizing sample with determination of oil condition. That's really important. And also we had experience such a leakages when shipping. Thus, we need to fill the sample bottle, not more. Only percentage of 80, that's enough. Flush the sample between 5 or 10 times. That's the similar before this point. As we mentioned before, really important, take a representative sample. We do not advise taking for sample from the sampling, but because all of this dirt and weird contamination particles can be set at the bottom of the point, that when we decide on taking sample, do not forget taking sample after machine before the filter. That's another issue. And take first sample approximately 5 milliliters to dead volume, because we need the representative sample. We need to circulate the system. When we get sample, we need to fill all of the information of their card. If you use the QR code, you need to be put inside, filling the blanks with correctly. After sampling, kept in plastic band, all types, tubings, hand pumps, etc. Because we need to prevent, we need to avoid of cross-contamination, because we can get unexpected results and also affect our taking actions in near future. And also you'll waste your time, you'll waste your money, and all of them you'll restart your process again. That's essential. Now, take a look at from laboratory side. We want from the laboratory all type of informations, such as oil and equipment type, oil and equipment service hours, top-ups, historical maintenance data, and sampling location, if possible. Oil and equipment type, because we choose the appropriate test suite for oil, for equipment. We want oil and equipment service hours because we want to define contamination and wear levels. We want the top-ups because if you don't mention the laboratory for topping up, you can see decrease of the wear levels and contamination levels next sample. We need to know that. That's really important. Historical maintenance data. For example, for diesel engines, you put inside your oil coolers broke down and you put inside the new oil cooler. Maybe you will see higher copper wear trans due to breaking in maybe with new oil cooler. But if I don't know that, I can diagnose such a bearing wear only, then take an action. But if this is only from oil coolers, maybe few oil changes after, you'll see lower copper wear levels. That's really important. Yes, now we are looking oil analysis. This is the second step. Actually, we are looking for three types of questions. Which tests? What for? Will oil still do its job? We are looking to viscosity. Primarily, is the lubricate between the metal surfaces. If not, there is a efficient lubrication, you'll probably see the metal-metal contact and abrasive wear levels occurred, or three body of wear levels occurred. That's cause increased wear levels. Is that indicating of any possible failure at the equipment? That we need to look at the oil analysis reports, contamination, such as water and particle results. Maybe it's diesel engine. We are looking for the coolant leakages, sodium, boron, potassium, or wear levels, iron, copper, lead, chromium. Is there an overheating? Is there possible piston seizure? That's really important. And another question is this equipment failure results of service oil in use? We need to check FTIR test for C, oxidation rates, soot particles, noise, nitration, possible glycol, etc. How close to oil end life? Another question is, if this is a gas engine, we'll check after next slides at the case study. We need to check oxidation rates, acid number, base number, and including IPH value. If this is turbine oil, I advise to check to see end life, ruler, RP watt, MPC values. In summary, all applicable tests depends on the equipment type and service oil in use. Third part of is diagnostic data. This is from my side. When I check the oil analysis reports, I'm checking oil and equipment type, oil and equipment working hours, wear and contamination rates, and characteristics of lubricant, additive levels, or lubricant properties, such as viscosity, or contamination levels, water contact, or indicator of coolant indicators. What type of oil? I don't know. This doesn't matter. And at the diagnosis stage, all of these mentioned information, that's really important before we valid the final report. We use all kinds of informations for diagnosis samples. When we detect a suspicious value, get retest for understand in abnormal measurement at the laboratory devices. After all, we check abnormal limits due to each components that may be different equipment such as gearboxes, transformers, marine engine oils. We are checking OEMs. And that's why I diagnosed more than 100,000 samples until today. Finally, take a look at benefits of oil analysis. Our goal is have information about the condition of the machine and the lubricant closely following the characteristics of the lubricant and wear and contamination levels. After this, we define the remaining life of the oil is analyzed as a result, early oil drain periods and prevented and optimum use is ensured. It plays a role early prevention of the problems that may occur with appropriate actions planned by detecting wrong oil top-ups. If there is a ISO 32 but you put inside 46, how can you imagine this? Increasing heatings or slow if this is a hydraulic, slowly move. Wear and contamination values are closely be monitored. That is play active role in extending equipment life as you are planning the predictive maintenance next trend. And maintenance operations, labor and equipment costs, loss of time, etc. Operation sustainability is ensured by minimizing material moral losses. That's really important. In the maintenance actions to be taken according to the results of analysis and chaos and confusion are prevented. That's why we need to oil analyze and further investigations such as vibration, ultrasound technologies or sensors. We need to use every technology if it's applicable. Take a look at this final case study that's I experienced last year related with the gas engine used oil analysis. That's very important for me. This gas generator, a capacity of 1.4 megawatt, operates in the facility. That's more aggressive pollutant is the hydrogen. This more higher pollutant. Yes. When the amount of the hydrogen disulfide remains above 500 ppm, the gas generator operated in this very long for long periods. These huge investments can be out of the warranty with higher costs. Take a look at oil analysis reports. From left to right, you can see the working hours, lubricant life, equipment life, working service on oil. And from this side, you can see here oil changing in 774 hours after oil changed. But somehow oil has been degraded considerably at 662 hours, working hours. Then we examined with the attached report with business manager, and we noticed that very rapid degradation here. You can check TNN, TBN, base number, acidic number, and you can see the wear levels here. And also you can contaminants from here. and the oil analyzer FTR results and IPH. Rapid degradation here. And when we noticed that very rapid degradation compared to previous sample, and we investigated the reason. When we get back from the facility, that there was nothing wrong with the facility. But since we were sure that such a rapid deterioration could only be caused by external parameters such as hydrogen disulfide, and we requested a control from the facility again. And as some of you know that the gas analyzers are used in biogas plants. And this device reports the percentage of composition of methane, carbon dioxide, hydrogen disulfide, nitrogen, and few gases in the instantaneously produced methane gases. In case of the failure in this service, this device, a handset and spare another device. Handset is also used for emergency response. When they put this gas analyzer, which did not give any response, any warning, after the second control with the handheld device, they noticed the actual hydrogen disulfide 2000 ppm. Imagine that. Then had the gas generator and shut down immediately. If the gas engine had been running for a long time with the N-oxidized increased viscosity of oil, or it would have to damage at least 40 or 50,000 euros. Imagine that. Or results of the bearing wrapping, abnormal overheatings, or piston seizure. In the meantime, the generator plant, which will not work for about 3 weeks, because could cause serious damage. That's why we noticed that oil analyzers give early signal. That's really important that as a result of this whole presentation, that's really important oil analyzers into your maintenance plans. Thank you for listening me. Thank you for everyone and the LRVC family again, and especially Sanya. Hopefully this presentation will be helpful for your operation. You can also contact with me from LinkedIn or by mail for questions. Thank you for having me again. Thank you for listening to me. Bye-bye.
Wow, that's great. I'll get big older, yeah.
Well, I found it very interesting. I like the way that you emphasize on the time taking the samples, and taking take the right time on the presentation to highlight the importance of having correct samples, and that's like the starting point of everything.
Yeah, that's the first step of the analysis. We can spare off each other. If you take a good sample, yes, you can do your analyze best. Each oil samples that gives huge information inside. Therefore, be care of the all type of oil can be sampling properly. Yeah, this is the first step. Yeah.
We have some participants. If you have any questions, now we are opening now for questions. If you want, you can submit your question or your comment through the chat function. We will display it.
Wow.
Yeah, satisfied audience.
Yeah, that's great.
Yes.
That's great. Thank you. Thank you.
All right.
All right, okay. I'll be online at the mobile app. If you want any question or meeting, I'll be online. Thank you. Thank you, LRVS family and Fleetech to you.
Thanks again, Umut, and yeah, keep up the good work.
Yeah, thank you. Hopefully.
Thank you very much. Be sure to follow all the other presentations at Lubrication and Reliability Summit, and see you next.